Good afternoon, my name is Avi Kantha. Today I will be presenting my Lab 3 circuits in Physics 2212. For my introduction, this lab aims to measure the magnetic field produced by a bar magnet, see how dependent it is on the distance. We'll be using a computational model called GrowScript to simulate the experiment ideal conditions. The experiment is also done in real life to show the experiment in realistic conditions. The assumptions are the bar magnet creates a magnetic dipole and the field goes away when the distance from the magnet is increased. The system is a magnometer and the bar magnet surrounding everything else. Some important laws we have is the Biot-Savart law and the magnetic dipole moment equations, and these will be important for the stuff we do in this lab. So some previous results there's an inverse relationship between B field and R, and then B field of axis is equal to that value and B field on axis is equal to that value. So our experiment is that we have to set it up in two different ways with the magnometer and the actual bar magnet as shown. So we have the on axis, which is on top, and the off axis, which is on the bottom. And we're moving the phone along the x axis in the first setup and along the y axis in the second setup. In setup 1, we got these results. We did 15 different distances and we grouped them into these specific categories and then found the averages. And then we graphed it using this equation and this linearly approximation equation, and we found that when R increases, meaning the distance increases, the magnetic field BFX decreases. And by doing some calculations using the magnetic dipole moment, we found the value of mu, and mu is equal to 11.42 J over T. And these are some of our values for the off axis. And we had to do a bunch of other stuff, obviously, because it's off axis, and we're also trying to account for the Earth values. So therefore, we have a corrected T value. Now we went to our GrowScript model, and now what we're doing is that we're just plugging in values. We had to find mu mag, and mu mag was already given to we found earlier, so we just had to plug that in. And now then we also did all the different observation distances down here, and also we put in the d per value, and then we put in an equation or a function for the dipole moment, which can basically find the dipole moment at any given location. So this is the results of our of the GrowScript model, and the arrows are indicating that the bar magnet is showing a dipole kind of magnetic field, and up here is our B, and our B value is 38.5 UT. And some possible errors that we could have encountered while doing this is that the Earth's magnetic field could have affected our results. There could be errors in magnometers, and surrounding electronic devices may have caused an effect on the results, causing an error, obviously. So what if we had an oriented experiment to compensate for the magnetic north, and instead laid out your meter stick in some intermediate angle with respect to Earth's magnetic field? How would your results have changed? So the Earth's magnetic field would affect our BFX values and skew our measurements. And what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? And two magnets together would produce a stronger magnet, and stronger magnet dipole moment, and stronger field. Our results would need to be scaled by a factor of 2. Thank you for listening to my presentation.